Hello everyone and welcome to the IAC 2022 in Paris. We are here on the booth of the SRI, EuroMoonMars, Lunex, and we're together today with me. I'm Roxana Perrier. I'm a space science and physics teacher at an engineering school that's called IPSA, and former analog astronaut at the EuroMoonMars Poland mission. I was the commander. I'm in charge of the outreach events for my students, but also outreach events organizing the future and next analog astronaut missions that are organized by the EuroMoonMars collaborators. So today we're together because I would like to tell you how the EMMPOL mission started. They started with the collaboration of three persons. Like we have Bernard Foing, the president of EuroMoonMars, and the president of Space Renaissance International. Myself for the IPSA, the engineering school, Air and Space Engineering School, and Agata Kolodziejczyk, who's the scientific director of the Analog Astronaut Training Center in Poland. So this collaboration allowed us to prepare the first EMMPOL mission that took place in October 2020. In order to do that, we did international weekly meetings. We participated at several workshops to end up in October 2020 with the first EMMPOL mission, EMMPOL 1, that took place from the 16th to 22nd of October. I was the commander, and I had three other crew members that were my students, and one vice commander that was a Polish scientist that I'm very proud and very honored to have met, Christian Komenda. And of course, we were followed by EMMPOL 2, who were our mission control center during our mission, and we became their mission control center during EMMPOL 2 mission that took place from the 23rd to 29th of October. Of course, an analog mission implies organization. So we had a flight director who was coordinating the mission control center, the Capcom, and the analog astronauts. Analog astronauts were producing data, transmitting to the Capcom, and then the mission control center will divide those data in function of the tasks to science, medical, or to the data analysis pole. Of course, that implies science that started from school projects to real science inside the moon base. That was, here you have the example of the uncrewed greenhouse that was projected in as an academic project, and then it was made inside the moon analog base in Poland. We also thought about logistics and started from our cube-shaped satellite that we wanted to send to space. This cube, actually not 3D printed but made out of aluminium, will fly in a zero-G flight campaign in the beginning of this October 2022. And you have the application inside the moon base, that is the micro 3D printed launcher. We were followed, of course, by our MCC and fielding sheets with all our data. We followed strict schedules that were imposed by our mission control centers, and we did science like life support, composting, sample returning systems, water budget, and monitoring space data, space weather. We had two crew members that were dealing with results in aquaponics and hydroponics, and dealt with the simulation of a power failure. And then we had another one that collaborated with environmentally friendly, and that's very nice because nowadays we talk a lot about sustainability, and this was the example of how we could compost materials that were used inside the moon base. Unfortunately, we need more data than this to conclude something relevant, but it's very exciting as first results. We also tested a high pH water. We tested for the first time a 9.4 pH water, and our results will be published soon. The data that were produced inside are still ongoing. The following missions after the EMMPOL 1 and 2 added data to this sheet. And then, of course, we monitored the carbon dioxide levels inside the base because that's very important while inside a closed environment. Our vice commander was dealing with reducing this CO2 levels inside the base, and he constructed a bioreactor based on three different micro consortia, three different algae microconsortia, and he had a lot of good results thanks to that. He managed to reduce the carbon dioxide level inside the moon base during our missions. And of course, our communication officer dealt also with the engineering part and 3D printed parts of a micro launcher that could bring samples from the moon's base to the low orbit. All these missions allowed us to participate to a lot of outreach events, more than 20 in 2 years, and we're very proud of the fact that nowadays EMMPOL missions are more and more known. Of course, we will continue, and we're inviting you to go to infinity and beyond. Just keep dreaming and go forward. Thank you for your attention.